Assalamu alaikum. Today we will talk about section 7.2, which is about trigonometric integrals. From the name, we will integrate trigonometric functions. In this section, we will treat three classes of functions. The first one, integral of sine x cosine x dx, where the sine raised to some power m and the cosine raised to some power n. And similarly, we will treat this class, tan to the power mx, secant to the power nx dx. And similar to this, we will treat integral of cotan to the power mx, cosecant to the power nx dx. In this section, we will not have a technique. Rather, we will have a strategy. I mean, I will give you a guideline, do this, and you will get the result easily using some algebra and manipulation. Let us start with this case. The power of cosine is odd. I mean, n should be odd. And remember, in mathematics, odd means it can be written this way, 2k plus 1, where k is an integer. So here we have the power 2k plus 1. Now, simplify this integral using algebra. I will write sine mx here, and here I will save cosine x dx. You will see the reason why. Once you save cosine x, then you are left with cosine to the power 2k, right? Allow me to write it this way, to the power 2, and I will put k over here. Now, we will use the identity. Cosine square equal 1 minus sine square. So here, it will be 1 minus sine square x all to the power k, and here you have cosine x dx. And just copy paste this. Now what do you have? If you take u equal to sine, then this is your derivative. So you end up with integral of function of sine x cosine x dx. That means if you take u equal to sine, then at the end you will end up with integral f of u du, which is very simple integral. I will summarize these steps in the following note. First, we will start with the strategy for evaluating integral sine to the power m, cosine to the power n, x dx. We have three subcases. If the power of cosine is odd, if the power of sine is odd, if the power of both sine and cosine are even. Let us start with this one. If the power of cosine is odd, as I said in the explanation, save one cosine factor. Then use this identity, cosine square equal 1 minus sine square, to express the remaining factors in terms of sine only. Then you need to put u equal to sine x. Just to simplify your life, understand this way. What you save is the derivative. My derivative is cosine. So what is my original function? It is sine. So I need the substitution u equal to sine x. This will be very clear once we go to the examples. Question number 1, he said integrate cosine cubed x dx. Well, we have the strategy. The power of cosine is odd, so follow this. Save one cosine, as I said. This will be, if you save one cosine at the end here, you are left with cosine square. Look here, we are looking for the substitution u equal to sine x, then we need to write the rest in terms of sine only. So what is this in terms of sine? It will be 1 minus sine square x times cosine x. Now we are in step number 3. Use the substitution u equal to sine x. Let u equal sine x. Then clearly my du cosine x dx. Look here, this is your derivative. So I am left with integral 1 minus u square. Simple integral. 1 minus u square du. Because everything here goes with the du. This is very simple integral. It is u minus u cubed over 3 and add a constant c. Tell me my u. It is sine x. So I will say sine x minus 1 over 3 sine x and put the power 3 here plus constant c. Let me summarize. We took cosine x. We save it at the end. We write everything here in terms of sine. Then we make the substitution u equal to sine x. Now we have another method to solve this exercise using the reduction formula. In fact, in section 7.1, we did the reduction formula for the sine. Similar formula can be found for the cosine also. And you can do it or simply use integration by part, because this is the idea behind the proof. You need to take dv to be cosine x, and whatever you have, leave it with the u. I mean, u will be cosine square x. If you do it, you will get the same answer. Now let us go to part B. If the power of sine is odd, it is similar to this. You need to save one sine factor. Then you need to use this identity, sine square equal 1 minus cosine square, to express the remaining factors in terms of cosine. Why did we do this? Because I am looking for the substitution u equal to cosine x. I summarize again. If you take sine factor outside, then this is your derivative. What is your original function? It is u equal cosine x, and this is your substitution. Let us apply it in the next example. Question number 2, he said integrate sine to the power 5x cosine square x dx. Clearly here we can see that the power of sine is odd. So let us follow this strategy B. He said save one sine, then write the rest in terms of cosine, then use the substitution u equal cosine x. Let us do this together. This will be sine to the power 4x, save one sine at the end. Now I am left with cosine square x. Now concentrate, this is my derivative, so write everything over here in terms of cosine only. This is cosine, write this in terms of cosine. How? This can be written as sine square x all square. What is sine square in terms of cosine? Yes, it is 1 minus cosine square x, and this is the power 2. Now copy paste the rest. Cosine square x, and here sine x dx. Remember, here I am looking for the substitution u equal cosine, so I will say let u equal cosine x, so my du is minus sine x dx. Remember, the cosine will be your u. This integral will be 1 minus u square all square times u square and sine x dx. Read it from here, it is du over minus 1. So I will write du here and minus outside the integral. This is very simple integral. Just do it and finish the solution. This will be minus. If you expand this, you will get 1 minus 2u to the power 2 plus u to the power 4, and you have u square outside. Now simplify a little bit. You will get the following. 1 times u square, this is u square, and multiply the rest, you will get minus 2u to the power 4 plus u to the power 6 du. This will be minus, integrate this, you will get u cubed over 3 minus 2u to the power 5 over 5 plus u to the power 7 over 7 plus constant c. My u is cosine, just plug it and that's it. It will be minus 1 over 3 cosine cubed, minus with the minus, it will be 2 over 5 cosine to the power 5x. And let us complete over here, minus 1 over 7 cosine to the power 7x plus constant c. Now if you see the recording, you may try integral sine cubed x, which is given over here. And this is the solution. Follow the same strategy. Again, we already did this exercise using reduction formula. If you do it by the strategy today, you will get the same answer. Here we have little note. Note that if the powers of both sine and cosine are odd, then either A or B can be used. Alright? Part C. If the powers of both sine and cosine are even, then you can use one of the following identities. Sine square x equal half 1 minus cosine to x, or cosine square x equal half 1 plus cosine to x. Let us see the proof. How to prove sine square equal to this? This is very important. Remember, what is cosine to x? We have 3 formulas. One is cosine square x minus sine square x. In fact, if you know this, you can find the others. What is cosine square itself? It is 1 minus sine square, and you have minus sine square also here. So if you combine these, you will get 1 minus 2 sine square x. In fact, this is what I need. Solve for sine square only. Subtract 1 from both sides. You will get cosine 2x minus 1 equal minus 2 sine square x. Now divide by minus 2. Now look here. It is the same formula. Sine square equal 1 over 2, 1 minus cosine to x. Maybe you can see it easily if you put this minus upstairs here. So you will get the same formula. Alright for this one. Now what about the other one? As I said, cosine 2x, it has another formula. You can see it over here. What is sine square? Isn't it 1 minus cosine square x? So if you expand this, you will say cosine square minus 1 plus cosine square. If you simplify it, you will get 2 cosine square x minus 1. Solve for cosine square, add 1 to both sides to get this equal 2 cosine square x. Now divide by 2 to get the formula. Let us read it over here. Isn't it the same as this? 1 over 2 times cosine 2x plus 1. Now we have little note. He said it is sometimes helpful to use this identity. Sine x cosine x equal half sine double angle x. I think it's clear. If you multiply by 2, you will see the reason for having this formula. You remember this? Sine 2x equal twice sine x cosine x. Now simply divide by 2. If you divide by 2, you will get half sine 2x is sine x cosine x, which is the formula over here. Alright, but this is the proof. Please know it. And also it is good to know the formulas. Now let us see an exercise for this part C. Question 3a. He said integrate sine square x dx from 0 to pi over 2. And here we have another part. You need to try it yourself from 0 to pi over 4 cosine square x dx. And here is the answer. Let us start by A. Just use the formula. It will be half integral 1 minus cosine 2x. Why this formula is helpful? Look here. If you change it to this form, we are not integrating yet. We are getting a nice form. The integral of 1 is easy. What is the integral of cosine 2x? Also, this is easy. Let me remind you with this quickly because we need this trick always. You need to use a substitution that is u equal to x. du will be 2 dx. Alright, this will be cosine u. What is dx? Read it from here. It is du over 2. And what is that? Clearly, this is 1 over 2 sine u. What is my u? It is 2x. Alright, plus constant c if you wish. So this integral will be 1 over 2. Integral of 1 is x minus. The first method is as follows. Integral of cosine is sine 2x, the same angle. But you need to divide by 2, as I did here. And be careful, we said this is true if you have a linear function. I mean of degree 1. Plug pi over 2 here, you will get pi over 2. Minus plug pi over 2 here, you will get sine pi. And that is 0. And do not forget to substitute by 0. Here you will get 0. And sine 0 is another nice 0. If you simplify these, you will get pi over 4. Now I will give you 1 minute to evaluate this or tell me what are the changes. Let me give you the idea. Look here. The only difference is to change this minus to plus. So the solution will be the same. This minus will be plus, this minus will be plus, this minus will be plus. But do not forget to change the boundaries. I mean from 0 to pi over 4. And for sure the substitution will be different. If you do it, you will get this answer. Now let us see one more question for this part. He said integrate sine to the power 4x dx. Here I have a quick note. This question is an example of the textbook and it came in some old exams. What is the power of sine here? It is even. So let us follow the strategy. So just use this here. Let me write this as sine square x all square dx. Then what is sine square? Clearly this is 1 over 2. 1 minus cosine 2x. And here the power 2. Now simplify. You will get the following. 1 over 4. Expand the power here. You get 1 minus 2 cosine 2x plus the last one square. Cosine square 2x dx. Now before we proceed to the solution, ask yourself, is the integral of 1 easy? Yes. Is the integral of cosine 2x easy? Yes, we have done it. What about the integral of cosine square 2x? Can we use this formula? Can we copy it, paste it? No. Look here. You have cosine square x. Look at the angle. The angle here is x. And here double of that. So if you have cosine square of 2x, then the formula will become cosine 4x here. And you have plus 1 here. And you have 1 over 2. That means do not touch this half. And do not touch this one. Just double the angle only. Alright. Now if you do it this way, then the problem is solved. Here we get 1 minus 2 cosine 2x plus this. This is given here. Alright, so let me expand. It will be 1 over 2 and expand here. You will get 1 over 2 cosine 4x. Just to clarify, this is given over here. Now let us integrate and that's it. This is 1 over 4. 1 plus half is 3 over 2. If you integrate it, you get 3 over 2x. Now let us integrate this. First, let me take the 2 outside. What is the integral of cosine 2x? Yes, we said sine 2x and you divide by 2. Alright, remember, this half is already done over here. Now what is the integral of this? It is the same story. Take 1 over 2 first. Integrate cosine 4x to get sine 4x and divide by 1 over 4. and add a constant c of integration. Now let us solve part B, integral sine square x cosine square x dx. This question will be solved using two methods. Method number one, we will use this, and method number two, we will use this little remark. The first one, what is sine square? Read it from here. It is half 1 minus cosine to x times, what is cosine square? It is the same stuff, but instead of this minus, you have plus dx. Now simplify. Half times half, this will be 1 over 4. And multiply the brackets. See it this way. 1 minus a times 1 plus a. It will be 1 square minus a square. Right? Difference of 2 square. So I will get 1 square minus cosine square to x dx. Now how can I move from here? Either you use the formula for cosine square to x. We just wrote it 1 minute ago. Or let us simplify. What is 1 square minus cosine square? Yes, you are right. This is sine square that angle, which is 2x. And do not forget 1 over 4. Up to now, I didn't integrate. I am just using algebra. Now, what is sine square to x? It is the same story here. Replace x by 2x. You will get here cosine 4x. So, allow me to write it. 1 minus cosine 4x dx. And you have 1 over 2. Let us see it over here. Replace x by 2x. You will have 1 over 2, 1 minus cosine. 2x here will become 4x. Alright, so this is what we use here. Look here, this is half, and this is 1 minus cosine 4x. If you simplify this, you will get 1 over 8. And what is the integral of 1? This is very easy, it is x. What is the integral of this? We are familiar with this, it is 1 over 4 sine 4x, and add your constant c. Now let us see method number 2. In method number 2, we will use this little note. We will say sine x cosine x equal half sine double angle. Remember, the question is sine square cosine square. We can write it this way, sine cosine all square. If we do it this way, what is the formula for this? Read it from here. It is half sine to x all square dx. Now let us simplify to get 1 over 4 integral of sine square to x dx. Now wait. We already did this example. Isn't it this part over here? So I will say complete. You will get the same answer. Now we will talk about the strategy for evaluating integral tan to the power mx secant to the power nx dx. But before that, let us recall the following identities because we need it in this strategy. Let us recall this identity. Sine square x plus cosine square x equal to 1. Well, we have two other formulas. Let us prove them. If you divide by cosine square every term over here, we get the following. Divide by cosine square to get tan square. Divide by cosine square, you will get 1. Divide by cosine square, you will get secant square. So this is the proof of the first formula. Another one is given as follows. Let us divide now by sine square. I will get 1. Divide by sine square, you will get cosine over sine, that is cotan, and for sure square. Divide by sine square to get cosecant square x. Strategy for evaluating tan to the power mx secant to the power nx dx. A. If the power of secant is even, then follow the following. Save a factor of secant square. Then use this identity secant square x equal 1 plus tan square, which is given over here, to express the remaining factor in terms of tan. Why did we do this? Because I am looking for the substitution u equal to tan x. I repeat myself. Once you take a factor of secant square, this is your derivative. So the original function will be your substitution, which is u equal to tan x. Similar to this, we have part B. It says if the power of tan is odd. Look here. For the secant, we need the power to be even. For the tangent, we need the power to be odd. Then we follow the following steps. 1. Save a factor of secant x tan x. Then use this identity, tan square x equals secant square minus 1, which is the same as this one, to express the remaining factors in terms of secant x. Again, we do this because we are looking for the substitution u equals secant x. See it again in a different way. If we save a secant tan, then the original function is u, which is secant x. Now somebody will say, what about the other cases? The textbook says for other cases, I mean if the power of secant is odd or the power of tan is even, etc., then the guidelines are not as clear cut. That means we do not have a guideline to follow. In this case, we may need to use identities, integration by parts, and occasionally a little ingenuity. That means little intelligence. So we will take one example here and one example here. Question number 5. He said integrate tan to the power 6 x secant to the power 4 x dx. Well, the power of secant here is even. So follow this strategy. So I need to save secant square. Write secant square at the end. So I am left with secant square x. Then I am left with tan to the power 6 x. Now look carefully. Forget about this. Do not touch it forever. This is your derivative. So the original function should be u. Cover this. I don't need to see this. My original function is tan. So I need to see here tan only. This is tan, ready. But this is not ready for me. Make it ready. So I will say the following. Tan to the power 6x. What is this in terms of tan? See the note over here. It will be 1 plus tan square x. And leave this as it is, secant square x dx. Now use the substitution u equal to tan x, because if you do so, you will get du to be secant square x dx. This will be u to the power 6, alright, because my u is tan, and this is 1 plus u square. And do not forget, everything here will go with the du. So this will be integral of u to the power 6 plus u to the power 8. du, this will be u to the power 7 over 7 plus u to the power 9 over 9 plus constant c. Just tell me the u and that's it. This will be 1 over 7 tan to the power 7x, because the u is tan, plus 1 over 9 tan to the power 9x plus constant c. And that's it for this question. Alright, let me give you a common mistake done by students. They will write this step and they will go to this step, but here instead of secant square they will write 1 plus tan square. Now if you play with this, then the question will take more time with you. Maybe you will take like 2 pages or 3 pages and you will not reach to any point. Alright, so please follow this strategy carefully. They are well written. So if you save a secant square, we are saving this in purpose to make the substitution u equal to tan x. Do you get the point of this section? Now let us see question number 6. He said integrate tan to the power 5 secant to the power 7 dx. Well, which strategy shall we use? Is it A or B? Is the power of secant even here? No. So do not look here. B, is the power of tan odd? Yes. So please follow this strategy. So in this case, we need to save a factor of secant tan. Write secant x tan x at the end. Remember, you took 1 from here and 1 from here. So this one will be tan to the power 4x. And this one will be secant to the power 6x. Remember, this is your derivative. So my original function is secant. So I need to see here only secant. This is secant, but this is not secant. So make it ready. This is tan square x all square. Alright, if you do it this way, what is tan square itself? Read it from here. It is secant square x minus 1. And do not forget this power 2. Now, leave this as it is. Don't play with it. It is secant to the power 6. And write this, because this is your differential. So I will say let u equal secant x. du equal secant x tan x. If you do it this way, you will get integral of u square minus 1 all square, u to the power 6 and du. This will be u to the power 4 minus 2u square plus 1 times u to the power 6 du. Simplify. Here you have u to the power 10 minus 2u to the power 8 plus u to the power 6 du. Integrate now to get 1 over 11 u to the power 11 minus 2u to the power 9 over 9 plus u to the power 7 over 7 plus constant c. Alright, now what is my u? It was secant. Now just put it over here and this is your solution. Now we will talk about important integrals. The first one is integral tan x dx is equal ln absolute value of secant x plus constant c. This is done in section 5.5. You can check it. Now we will see integral of secant x dx, which is equal ln absolute value of secant x plus tan x. Let us see it here. The idea behind this question is to do the following trick. You multiply by secant x plus tan x, up and down. Then you simplify. Secant by secant is secant square. Secant by tan, secant tan. And the denominator stays the same. Look here. If you take u equals secant plus tan, which is the denominator, then the derivative is upstairs. Check here. The derivative of tan is secant square. The derivative of secant is secant tan. So we are done. So let u equal secant x plus tan x. The derivative will be secant x tan x plus secant square x. See it. Everything here is u, and upstairs you have du. So our integral will be du over u, because we said upstairs we have du and downstairs we have u. Here is ln absolute value of u plus constant c. Our u is secant plus tan. Put it to get the final answer. Ln absolute value of secant plus tan x plus constant c. Now it is good for you to find the other one, which is the integral of cosecant x dx. I will give you the details quickly. For the integral of cosecant, we need to multiply by cosecant x plus cotan. You see it here, up and down. If you simplify, you will get cosecant by cosecant, cosecant square. Cosecant by cotan is given over here. Now take the denominator to be your u. If you take it, your derivative will be minus cosecant cotan minus cosecant square, which is upstairs, but you need to adjust it with a minus. So you will have minus du upstairs, and in the denominator you have u. This integral will be minus ln absolute value of u plus constant c. If you simplify it, you will get minus ln absolute value of whatever you multiplied. Alright, there is one way to do it. Another way is to multiply by cosecant x minus cotan x, up and down. If you simplify, you will get cosecant square. Cosecant by cotan is given here, and the denominator stays the same. Now let us take the denominator to be u. du is upstairs. Check it. The derivative of cosecant is minus cosecant cotan. The derivative of minus cotan is cosecant square. So you will get du over u. This integral is ln absolute value of u plus constant c, which is equal ln absolute value of the denominator. My point is as follows. Look here and look here. What are the differences? In fact, they are the same. If you simplify this, you will get this one. Alright? If you use the plus virgin, I mean the plus inside, you will have a negative outside. If you use the negative virgin, I mean the negative is inside, then outside you will have plus. Please try to do this yourself again. You will get it easily. Now let us see question number 7. It says find the integral of tan cubed dx. We will solve it using two methods. Method number 1 as follows. Here only tan x occurs, so use the identity tan square x equals secant square minus 1. That means you save tan square and you write the rest, which is tan x. In fact, this is the idea of the proof of reduction formula. In section 7.1, the idea behind the proof is this. You take tan square and you write whatever you have. Then you use the identity for tan square, which is secant square minus 1. Then you expand. Let us see. As I said, tan square is secant square x minus 1. Tan x, you write it as it is. Now you simplify and you expand. Secant square by tan, I will write it this way. Tan x secant square x dx. Then you have minus integral of tan x. Now you remember the integral of tan x is already done. It is minus ln absolute value of secant x plus constant c. Look here, the minus is given here. Alright, now how can we deal with this question? We have two ideas. Look at the notes over here. If the power of secant is even, which is our case here, so let us save factor of secant square. It is already done. Let us write the rest in terms of tan. Done. Let us use u equal tan x. Let u equal tan x. So clearly here, this will be du, and this is my u. So the left integral only will be integral of u du. This is half u square. Now tell me my u, it is tan. If you plug it back, you will get half tan square x plus this integral, which is already done. So this is the final answer for this exercise. Another way to find I1, which is this one. Look here, the power of tangent is odd. So let us follow this strategy. So save secant tan, it is already here. we are left with secant x. Right, double check. Secant by secant is secant square and tan x is already here. Let u equal secant x. This is my u and everything here secant tan x is my du. So this integral will be u du, which is equal half u square plus 2 plus constant c, which is equal half my u is secant square x plus constant c. Some students will say we get half secant square and here we get half tan square. Are both forms equivalent? The answer is yes. See it here. Simply use the identity secant square equal 1 plus tan square. If you expand this, you will get half tan square plus half plus the constant. Now look here. Half tan square is given here and here. Now let us combine this number half, which is a constant, with this constant to give us a new constant. Let us call it C1. So at the end of the day, we get the same solution. Now we will solve this question again by another method from scratch. Look here. The power of tan is odd, right? So let us follow this strategy. Let us save secant tan. One will say, I do not have secant. Simply multiply and divide by secant as follows. This is secant x tan x. Alright, since we multiply by secant, let us divide quickly by secant x. We have tan, so I am left with tan square. Double check. Tan square by tan is tan cubed. Secant will be gone with the secant. So everything is correct. Write the rest in terms of secant only. This is secant square x minus 1 and do not touch the others. This is secant and this is secant x tan x. What is next? Let u equal to secant. If you do it, then this is your du. So the integral will be u square minus 1 over u du. Remember, my u is secant. So let us simplify this using algebra. U square over u is u minus 1 over u du. This is half u square minus ln absolute value of u plus constancy. Remember, my u is secant. Plug it back to get half secant square x minus ln absolute value of secant x plus constancy, which is the same solution given in method number 1. Remember, we said half secant square and half tan square, they differ by a constant. Alright? So what is my point here? My point is, if possible, learn many methods as much as you can. Do not restrict yourself with one method only. Note, if an even power of tangent appears with an odd power of secant, it is helpful to express the integrand completely in terms of secant x. Why? Because powers of secant may require integration by parts. See question number 8. Let me clarify this more. For the power of tangent, we need it to be odd to apply the strategy. And similarly here, we need the power of secant to be even. But here we have the other way around. The power of tangent is even and the power of secant is odd. If you have both of them at the same time, then he said, write everything in terms of secant and you may use integration by parts. Question 8. Evaluate the integral of secant cube dx. As in the note above, we need to use integration by parts. And by the way, this is a famous question. I will take dv to be secant square x dx and I will take u to be secant x. Why did I do this? Because we need dv to be easily integrated and this is easily integrated to give tan x, right? Now let us find du. It is secant x tan x dx. Now let us put our arrows like this. So our integral I will be secant times tan minus integrate horizontally tan x times this to get secant x tan square x dx. Now we will use the note. Look here. The power of tan is even. Look here. Even power of tangent. And the power of secant is odd. Right? See here. Odd power of secant. Then what shall we do in this case? Write everything in terms of secant only. So let us use this identity. Tan square equals secant square x minus 1 dx. Let us expand more. Minus secant by secant cubed. This will be minus integral of secant cubed dx. Again, minus with the secant with the minus 1 will be plus integral of secant x dx. Alright, let me copy this here. Now wait. What is the integral of secant cubed? It is our I, right? So I will say this is my I. Then I need to put it in the other side to get 2i equal whatever I have here. This is secant x tan x plus, what is the integral of secant? We already did it. This is ln absolute value of secant x plus tan. It is good for you to know this one because it occurs a lot. Now I need I, so divide by 2. So the final answer will be I equal half secant x tan x plus ln absolute value of secant x plus tan x. Now since we are done, do not forget to add a constant c. Now let us recall what we did in this section. First, we consider the class sine to the power m cosine to the power n. Then we consider the class integral tan to the power m secant to the power n. Now let us finish with this class. To evaluate the following integrals, use the corresponding identity. These integrals are integral sine mx cosine nx, integral sine mx sine nx, and integral cosine mx cosine nx. What are these identities? Look here. Sine a cosine b equal half sine the subtraction plus sine the addition. Also, sine a sine b equal half cosine the subtraction minus cosine the addition. The last one is cosine a cosine b equal half cosine the subtraction plus cosine the addition. What is the idea behind this? Look here. We have product of trig function and we end up with addition of two trig functions. Let us understand from where we get these formulas. Look here. What is the formula for sine a minus b and sine a plus b? It is sine cosine cosine sine. Let me repeat. Sine cosine, you have it. Alright? Now let us see the other two. Cosine the addition or the subtraction, it is cosine cosine, read, it is here. And sine sine. So this is the reason for having these formulas. Let me give you the proof for the first one so that you understand the full picture. Now we will prove part A, which is sine A cosine B equal half this. We need to start with the right hand side because it is easier. The right hand side will be half. Now expand sine A minus B. I already said this. It is sine cosine, then cosine sine. Here you have A, B, then A, B. Since you have a minus, then it will stay here. We finish with this. Now what about this? It will be the same, but instead of this minus, you will have plus. So I will copy it and let us close the bracket. Now look here. This term is equal to this term, but one of them with a minus and the other one with a plus, so they will cancel each other. So I am left with half. This term plus itself will be twice itself. 2 with 2, so we end up with sine A cosine B, which is nothing but the left hand side, which is this one. I advise you to do the proof for part B and C so that in the exam you will not miss it. Now, if you need to memorize it, all of them they contain half. And remember, for sine A cosine B, it comes from where? Sine the addition or the subtraction. So you have it here. And similarly the others. And also note, A minus B comes first, then you have A plus B. All of them have pluses except the middle one, which is sine sine. It contains a minus. Or memorize it using any method you like. Now let us apply it. Question 9a. He said, find the integral of sine 4x cosine 5x dx. This question is very, very easy if you know the formula. And it will be a disaster for you if you do not know that formula. So please, know the formula, know its proof. This is an easy question. The corresponding formula clearly will be A, right? Because you have sine and cosine. So simply I will say integral of half. I am not integrating yet. I am just writing the formula. It is sine A minus B. Look here. The formula is very sensitive. You subtract this way. A minus B. That means we subtract 4x minus 5x. And that is minus x. Then we have a plus. Then sine the addition, which is clearly 9x. Let us simplify a little bit. This is minus sine x because the sine function is odd. Now let us integrate to get the following. The integral of minus sine x is plus cosine. To see it, the minus is here. The integral of sine is another minus cosine x. What is the integral of sine 9x? Yes, it is minus cosine 9x. And do not forget we divide by 9. We said this a lot in this course. Plus constancy. Now let us take 3 minutes to evaluate B and C. Alright, time is up. Let us start solving part B quickly. Clearly the corresponding formula is the last one over here. So simply I will say half integral cosine the subtraction, as I said, 5x minus 10x. This will be cosine minus 5x plus cosine the addition. Clearly this is cosine 15x from 0 to pi over 2. Now let us simplify. This will be cosine 5x because the cosine function is even. So it will eat this minus. Now if you integrate, you will get 1 over 2, 1 over 5 sine 5x plus 1 over 15 sine 15x. And you need to evaluate from 0 to pi over 2. If you put 0, everything will be 0. If you put pi over 2, this is 1 over 2, 1 over 5. Sine 5 pi over 2 is 1. How can we see this? Look here. This is pi over 2 and this is 3 pi over 2. So 5 pi over 2 will be here. So the sine here will be 1. Plus 1 over 15. What is sine 15 pi over 2? Let us see it this way. Pi over 2 here. 3 pi over 2 here. 5 pi over 2 here. 7 will be here. 9 here. 11. 13. 15 will be here. So the sine here will be negative. And if you evaluate this, you will get 1 over 15. Alright, what about part C? I think this is very easy. Clearly we need to use part A, but we need to modify it a little bit. Look here. The formula started with sine. So first, write the sine, which is sine 8x, then cosine 5x dx. I will be 1 over 2 sine the subtraction, sine 3x, plus sine the addition, which is 13x, and here I have dx. Clearly, if you integrate this, clearly you will get this answer. Check it. And this is the end for section 7.2.